Today we're going to talk about what the heck is aperture. Imagine a water tap in your house. You can control the water flow by turning it. You can let a little bit water out by turning this a little bit. You can let tons of water out by turning it a lot. Aperture just works like a water tap, but it doesn't control the flow of water, it controls the flow of the light. It controls the flow of light by twisting the blades. You can see in this picture there are 6 blades. The blades can move inward or outward. When the blades move inward, the aperture gets smaller. While the blades move outward, the aperture gets bigger. We normally use a series of numbers to describe how big the aperture is. Normally you will see the smallest number around 1.4, while the biggest number around 16 or 22. For novice photographers, what is mind-boggling is the smallest number means the biggest aperture, while the biggest number means the smallest aperture. So what do these numbers mean? To understand what this number means, you need to understand how the number is defined. In order to show you guys, I have drawn this simplified version of a lens. So as you can see, as the light travels from the right side into the lens, it gets focused on the left side. And the distance between the focus and the lens itself is called the focal length. And the width of the opening of how much light can travel through the lens is defined as aperture. So for the number fx, the x is defined as the ratio between the focal length and the aperture. So when the x gets bigger, it means the aperture is relatively changing, getting smaller comparing with the focal length. While when x gets smaller, the aperture is getting bigger relative to the focal length. To understand the definition better, let's talk about a particular lens. One of my favorite, the Nikon 15mm f1.4G. So 1.4 here means when the lens fully opens its aperture. The 50mm, the focal length, divided by the aperture is 1.4. So from this equation we can actually calculate when the lens fully opens. The biggest aperture is about 35.71mm. Now you understand the definition of this number. So now let's turn back to this slide. Have you seen any pattern in this slide? Don't worry, I'll let you see what the pattern is. Have you noticed that those numbers increase by multiplying 1.4? Why is that? In short, it's because the value of square root 2 is about 1.4. To understand what square root 2 is doing here, you need to go back to your geometry class and think about how to calculate areas. So let's look at the apertures in f2 and f2.8. So the aperture in f2 is actually as 1.4 times as big as the aperture in the f2.8. However, the area grows exponentially at the power of 2. So the area of the aperture in f2 is actually twice as big as the area of the aperture in f2.8. Similarly, the area in the aperture in f2 is 4 times as big as the area of the aperture in f4. The reason we have such numbers, f1.4, f2, f2.8, is because we need an easier understanding and estimation of how much light travels through the lens. As the number goes up, less light travels through the lens. And every number doubles by 1.4 times, the light reduces by 50%. So the light travels 50% less in f2 comparing with the light travels through f1.4. So that gives the photographers a better estimation of how much light reached the sensor. At last, I'd like to show you guys the biggest aperture autofocus lens ever produced. It was the Canon 50mm f1L. This lens was produced in 1989, and it is the currently world record for the biggest aperture autofocus lens. Thank you very much.